2.2 talks about graphs of polynomial functions, all right? Polynomial means many terms. We're going to talk about graphs that are like to the 5th power, to the 6th power. We're going to find the end behaviors, and you're going to find the x-intercepts, and you're going to find the multiplicity and all that good stuff. After Monday, you'll understand what all that means. You'll understand half of it right now. But the graph of a polynomial function is continuous. What does that mean? What does the word continuous mean? Okay, it goes on forever, something like that. If you put your pencil down on a polynomial function, you're going to have ups and downs. You're going to have bumps. But you will not have any gaps. There's no breaks. There's no sharp turns. So like some of those things that we had on our quiz when we were finding the domain and range, those weren't polynomial functions. They were functions of some sort, but they weren't polynomial functions. Your polynomial functions are just going to have a bunch of ups and downs and all that good stuff. You'll be able to tell me how many ups and downs there are, what the ends of the graph are doing. You're only going to have smooth curves, you'll see. You only have smooth curves. They're going to be rounded turns. How do you know how many turns there's going to be? Well, n minus 1. That's the number of turns. You guys are like, what are you talking about? N is your highest degreed exponent. So say you had x to the 5th. That's the highest exponent you had. How many bumps would you have in your graph? How do you figure out the bumps? What's the highest exponent? That's your n value. What's the highest exponent you see there? 5. What's 5 minus 1? 4. So you'll know, because you're going to have to sketch a graph. By the end of the day on Monday, you're going to have to be able to sketch a graph, and it's pretty simple. But if your x, whatever the highest exponent is, you say that number minus 1, and that's how many bumps you should have in your graph. So in this case, there's 1, 2, 3, 4 bumps. So what's the polynomial? What's the highest exponent in this polynomial? 5. There you go. So what we're going to talk about right now is the end behaviors of the graph. End behaviors. What's going on at the ends of the graph? You're going to be able to tell that, like I said, there's no sharp turns. You're going to be able to tell that just by looking at the exponent and the leading coefficient. We'll talk about it in a second. Smooth and continuous. N is the highest degree of the polynomial. When you talk about a graph, the greater the value of n, the higher the exponent, the flatter the graph is near the origin. Just some things to understand. Meaning, like, if you have a really high exponent, then your graph is going to be like this towards the origin rather than really high up and really high down. That's all that means. Something that is really important for you guys to remember, and this is where we're going to start talking about end behaviors, is if your graph is even, meaning n is an even number. Not necessarily the graph itself is even, but if the highest exponent is even, right? If the highest exponent is even, the arrows at the end are going to go in the same direction. We already knew that because even functions, arrow goes the same direction. Odd functions, they go in opposite, right? So when we talk about end behaviors, if the highest exponent is even, that means you know at the end they're either both going up or they're both going down, depending upon if it's a positive or negative. If the highest exponent happens to be an odd number, what are the directions of the arrows? Opposite. Perfect. And how do you know what's what? Well, let's think about this for a second. If we're talking about even functions, so squared to the 4th, to the 6th, to the 8th, so on and so on. There's only 2 directions that your arrows can go. They can either both go up or they can both go down, correct? You might have a bunch of bumps there in the middle, but both the arrows up, both down. If your function is odd, 1st power, 3rd power, 5th power, 7th power. When I say the function being odd, I don't mean algebraically it's odd, but the highest exponent being odd. Your arrows go in opposite directions. So sometimes it's hard to visualize. You guys are like, what are you talking about? This will make a little more sense in a minute. But I want you to think of a basic line. Is a basic line considered odd? Is the highest exponent odd? Yes, first power, right? So if I have a basic line, what are the ends of the arrows doing if it's positive? They're going in that direction, right? If it's a negative line, they go in that direction, correct? That's what you need to remember right now. If your highest exponent is even, both up, both down. If your highest exponent is odd, it's going to be in opposite directions, and you have to think if it's positive or negative. So this is how we use what's called the leading coefficient test in a second. If your function, the highest exponent, is odd, do you notice how the direction of the arrows is in opposite directions? Think of a line. This would be a positive line. Arrows going up to the right, down to the left. If it's negative, they're still going in opposite directions, but it's sloping downward like a downward line. So it's going up to the left and down to the right. So we're going to use that thinking, tiny little picture, to describe what's called the end behaviors of a graph. It's easier when the highest exponent's even, because if it's even and it's positive, which way are they going? Both up. If it's even and the function is negative, which way are they both going? Both going down. So let's talk about the leading coefficient test. It says use the leading coefficient test to describe the right hand and left hand behavior of a graph. So this is what we're going to do. We're going to determine the end behaviors. I'm going to just call it EB. And after we do a few of these, you're going to be like, oh, this is easy. Okay, so how do we do this? Locate the highest exponent. What's the number? 3. So 3 is what kind of a number? Odd. So when I think odd, I think opposite. So the direction of the arrows is going to be one up, one down. Which way? Well, think about this. It's negative. So think about a negative line. What does a negative line do? Slope upwards or downwards? Down, right? So just draw a little picture. Now, we read a graph from left to right. So you describe end behaviors from left to right. I always put an L here and an R here, and I circle the ends because that's what I'm looking at. We're going to use the words rising and falling. Rising means going in which direction? Up. Falling means going in which direction? Down. So you would tell me that this graph is rising left and falling right. That is the end behavior. That's what the graph is doing at the end. Because it's an odd exponent, the directions of the arrows are opposite, and because it's negative, it's going to resemble the negative line, a negative cubic, something like that. But they're in opposite directions and they're sloping downwards. Does that make sense? Okay, so how do we go about end behaviors? First thing we look at is the highest exponent. The highest exponent is a 12. What kind of number is 12? Okay, so even, I think, same. It's definitely easier when it's an even function. Okay, the direction of my arrows is the same. So I'm going to draw a little picture. We're talking about end behaviors. Are both of the arrows going up, or are they both going down? Well, what determines that? The leading coefficient. They're both going which direction? Yep. It doesn't look like a parabola. It's got a bunch of bumps in the middle, but you're talking about the ends. So when I read from left to right, what are you telling me is happening on the left and on the right? It's falling left and falling right. Perfect. Good job. People say, how do you show your work? Exactly like that. If you write it down, it really makes it very simple. Write down the L and the R for left and right. You read from left to right, you read a book. That's how we read a graph. All right, highest exponent. 9. What kind of a number is 9? And I think opposite. So let's talk about a picture. Is this going to resemble a positive line or a negative line? Negative. It's going to be going downwards. So talk about the left-hand side, talk about the right-hand side. What are we doing on the left? Rising left and falling right. Perfect. It's an L with a comma. All right, don't get tricked by something like this, guys. What's the highest exponent you see? 7. Not the first one, the highest. So that's the term we're looking at. 7 is what kind of a number? Odd. So we think odd and opposite. Is that a positive 5 or a negative 1? Positive. So it's going to be like a positive line. So what's going on the left? What's going on the right? It is falling left and rising right. Does that make sense? When they say the leading coefficient test, that's what that means. Think about what leading coefficient is. It's the number in front of the variable that has the highest exponent. It's like the line leader. So if you want to rewrite it, put it in order, that's fine. Or if you could just circle, just make sure that the sign in front of the term stays with it. All right, we have talked about this terminology before. When you find the zeros, right now we're finding real ones. In a couple days, we're going to be finding all of them, so real and imaginary. But there are different words that mean the same thing. Zero, solution, factors, x-intercepts, all of those things mean set y equal to 0 and solve it. 90% of the time, we're going to factor. But remember, guys, if you have like x to the 4th plus 6x squared minus 7x plus 1, and I asked you to solve this, how many answers should you get? 4. That's 4. Whatever the highest exponent is will tell you how many answers you should get. Now, they may not all be real. Some might be imaginary. We're going to get to that in a couple days. But you should get 4 answers. You need to remember that because that's going to pop up a lot. So let's look at a question. On your quiz, you'll have a question. It'll give you something like this. It'll say, describe the end behaviors. Do we know how to do that? What's the end behaviors of this graph? Highest exponent is a 3. So odd and opposite, right? Is it positive or negative? So it's going upwards like that. So what's going on the left? What's going on the right? Perfect. Falling left, rising right. 10 minutes ago, you guys were like, I have no idea what you're talking about. Now you're like, oh, it's easy. Now it says find all the zeros. Well, how many answers should I get? 3. How do you find the zeros? You set y equal to 0 and solve. So I have x cubed minus x squared minus 2x equals 0. How do we solve this? What's the first thing we look for? GCF, is there one? Yep. So then I have x squared minus x minus 2. We hope and pray here that this factors. If it doesn't, you have to use the quadratic formula. Luckily, this one does. So I have x. What times what gives me -2 when I multiply, but a -1 when I add? -2 plus 1. So my 3 x's are x equals 0, x equals 2, and x equals -1, correct? So on a quiz question, it's going to give you this, any kind of polynomial, it's going to say, what are the end behaviors? You know how to do that. It's going to say, find the zeros. You know how to do that. The next thing it's going to say is, what is the action at the x-axis? We're going to talk about that on Monday. And then you're going to have to graph it. What I mean by graphing, the only thing I need to see with graphing is where it crosses the x-axis, what it does at that point, and what are the end behaviors. So it's really not hard for you guys to do. Once you determine where it crosses, where are the 3 places that this crosses? 0, where? 2, and -1, okay? I don't care exactly. Just make sure that -1 is on the left of 0 and 2 is on the right. Not a big deal. So think about what your graph should look like. How many bumps should it have? How many bumps? 2 and -1. So your graph's going to have 2 bumps in it, okay? What do the ends of the graph look like? You already told me. It's falling on the left-hand side, so it's going down this way, and it's doing what on the right-hand side? It's going up. Now, we're going to talk about action at the x-axis on Monday. Sometimes it goes through the point. Sometimes it touches it and turns, or they say bounces. I'll explain to you why that happens. But what you would do to graph it is you'd go here. You go, okay, it goes through here, and back up there. And there's your graph. The reason that it goes through is because you have each of those values, -1, 0, and 2, you only have it one time. But if you have something like, say you don't have to write this down, but say you had x squared plus 6x plus 9, right? If I factor this, what does that equal? X plus 3 and x plus 3, right? So your x value is -3. That's where the graph touches. But how many -3s did you get? You got 2 of them. So what happens when you have multiplicity an even number of times, and again, I'll talk to you about this later. Here's my -3, right? What's the end behavior of this graph? What's the highest exponent? A 2? So that means both the arrows are going in what direction? Both up, because it's positive, right? So how could you get this to go through the point, but then come back through the same point, because it only has one intercept? Because you have the same value 2 times, what the graph does is it goes to the x-axis, it bounces off, like that. Whenever you have the highest exponent being a 4, you usually have multiplicity. 6, something like that. It's where it touches the x-axis and bounces the other way. That's how you get the arrows to go in both same directions. We'll talk more about that on Monday. But a majority of this lesson is already done just by the leading coefficient test, how to find the end behaviors, and then to factor to find the zeros. We'll talk about graphing and multiplicity on Monday.